About 3 weeks ago, I competed in a global hackathon called Build It with Claude Opus 4.6. It was hosted by Anthropic, and I came in second place. And this Elisa IDE was my project. Um, I've been building it out more for the past 3 weeks, and I wanted to give an update and kind of show off what it looks like today. And it's available for use if you're interested in playing with it. So what is it? It is a visual development environment. It's block-based, and it brings in the primitives of agentic programming via blocks and allows kids to do agentic programming today. The entire thing is spec-driven development, and so I'll show you how to write a specification using this block infrastructure, and then show you what it looks like to go through the build process with an agent team, and then deploy it. So let's see if we can define and build a Space Invader game in a few minutes here. This is the Elisa IDE. On the left-hand side, you can see the block canvas. On the right, we've got tabs for the workspace, for mission control, system view, tests, and our agent team, which we'll look at. Every specification starts with a goal. This is how we define context for what we want to build. And so we're just going to go ahead and, using regular old English, give a goal for this build. I want to build a Space Invaders game. And that's it. That's one sentence. And the goal alone is vague. I could, in theory, hit go right now, and my team of agents would try to build me a Space Invaders game. However, it gets a lot more interesting when we add requirements. And those requirements are what explicitly allow us to express our intent. Most powerfully, we get to do that without writing a single line of code. So let's go ahead and say we want to start from a template. So I want it to be a game, and let's grab the requirements. Now here we can see the different types of requirements blocks. The first feature that I want to add is going to be basically telling the agents that I should have 3 lives, the game should have a score counter, and we should have high score tracking. So I'm going to grab this block here and just connect it to the bottom. 3 lives, score tracker, and high score tracking. Then I will go ahead and add a second requirement. This one will be aliens move faster, and add a row each wave. Now what I'm doing here is I'm specifying the gameplay, just with human language. I'm not having to write any code or anything. However, what's missing, and this is where it gets very powerful, is I can add behavioral tests. So let's go ahead and open the test palette, and I can just nest these tests directly underneath my requirements. Let's go ahead and type in when all aliens, see if I can type correctly, in a wave are destroyed, the next wave starts with more aliens that move faster. And again, this is just a plain English sentence, but it's also a real verifiable test, and the agents can write this test code for me that can check the behavior that I'm specifying. So here my intent is the test specification. And actually, I'm going to drop that one here, grab another one. Let's see, for this one, when the player loses all 3 lives, A game over screen appears with high score and restart option. All right, now we can give some style hints for how we want the game to look. I'm going to say let's have it look like space is just a built-in style. If I wanted to, I could also go to skills. There are skills that we can use to give our agents more information about what we want. And I could say pixel art. So let's say we're going to add that skill. If I go to the skills tab, we'll give it retro arcade style, and we'll give it our pixel art. And I could create whatever skill I wanted for whatever feel I wanted. And lastly, we need to tell it what the output is. So in this case, we're going to have it put it on the web. And with that, just a few blocks, we've defined a specification for a Space Invader game. And what I can do now is I can go ahead and I can hit go. Now, as soon as I hit go, we switch over to mission control, and we can see that our agent team is mapping out the tasks. They're going to build a directed acyclic graph. So once that's built, it's going to outline what tasks the agents have to build in what order, figure out what files to create, what depends on what, and how to parallelize the work if possible. All right, and here is our plan. We've got, what do we have here? 7 tasks. The first task is already underway. We're going to scaffold the game structure. So in the background, we have an agent that's going and defining the structure of the game on disk. It's defining how the game's going to run. We have a task here highlighted in orange because it's blocked by an agent meeting. That meeting is going to be with Pixel, our design agent. We're going to talk about the design of the spaceship. Below that, a task for the alien grid, the spaceships that'll drop down. I'm guessing we'll have to have a design meeting with that as well. And because that's a blocking meeting, let's go have it. So if we go over to our Teams tab, we can see our agent team. These are all the different agent personas we can interact with. And the Pixel agent has surfaced a meeting request. So I'm going to say chat. And now Pixel is going to tell us exactly what we need to design. So player ship and shooting. Here's the fun part. We are making a cool pixel art player ship for your Space Invaders game. Wonderful. How do we want it to look? Cyan. Ooh, electric cyan is a great color. I would like a star field in the background with parallax. And we can just go through and have a conversation with this agent on exactly what we want the game to look like, in this case, what we're designing. And as we go through, the agent will update our canvas here on the right-hand side to give us an idea of what it looks like. Okay, that all sounds good. Now, I know right now our mission control is currently gated by this meeting, so I'm just going to hit save and end, and Pixel will take the design we've worked together on so far and pass that over to the next agent. Now, immediately we get another meeting surfacing here because the next step is a gating meeting there as well. So we can see our player ships being built out, the one we just defined. Let's go ahead and join this meeting with Pixel. And so again, Pixel is going to tell us what Pixel needs from us here. We're looking at the alien grid. What should they look like? Good question. Let's make them look cool. I think they should really stand out from the background. All right. And this is just another conversation we get to have with our design agent. This does 2 things. It helps us to really define how our game looks and feels. And also, because there's an LLM on the back end, the build process takes some time. And we are using that time to make our game better instead of just kind of sitting there waiting. All right, cool. Aliens it is. Yep, I'm thinking we could use bright colors. Sure, I like it. Let's make them menacing. All right, and let's just take that design and run with it. So over here we can see we're still working on our player ship. We have done our design here for our alien grid. It looks like we just finished the player ship. Alien grid work is beginning. So now we're going to service another meeting. Notice here we have a learning element that surfaced. And so in the background, we have our system making local commits through Git at each different phase, tracking our progress. And that learning was just telling us that. If we go to our tests, which we haven't seen yet, as work is being done, we start by defining tests that fail, and then the agent writes the code to make the test pass. So we can see testing around the work we've done is green. The work under progress has the failing tests. On the Teams tab, we've got 2 meeting requests. We have our buddy. Our buddy always services about 25% through the build. And the buddy is just a high-level agent that we can interact with to ask questions about what's going on, why it's going on, anything we want about the build itself. Why do we have 6 failing tests right now? All right, and then buddy will come back and tell us what's going on and why there's 6 failing tests, what Cosmo Builder is doing. And let's go ahead and get out of this meeting with Buddy because Pixel wants to chat about the next design element. And about halfway through the build, a meeting request from Scribe is going to surface. We should see that pretty shortly. Okay, now we're looking at the heads-up display and the game over system. All right, it looks good. I want the screen to flash when the ship gets hit. All right, and Pixel is asking us questions about how we want it to look specifically. Let's have a lightning bolt. I don't really know what that means, and I'm curious to see how it comes across. There it is, lightning bolts. Wonderful. Let's save and end because we can see that our next step is a gating meeting as well. So if we go take a look at our tests, all right, green, 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 that's good. Red for the ones we're implementing right now. Very cool. And what's happening in the background right now is pretty interesting. So each task is executed by an AI agent using the Claude Agent SDK. Right now we're using Claude Sonnet 4.6, but that is definable by the user. So you can pick Opus, you can pick Haiku, and there are trade-offs there around cost and around speed. The agent gets a system prompt with its role. So when we launch the agent, it gets that system prompt. That prompt is partially defined by previous meetings we've had with agents. We can inject that context in and really guide our agents as they do their work. And each agent knows what was already built because they get feedback from the previous agents. And so they're not working in isolation. There's a context chain that connects them. Let's go see what Pixel wants. Okay, the wave progression system. Right now, when you beat all the aliens, we need to show players they're moving to the next wave. We get a pop-up that says wave 1. Yep, glowing cyan sounds great. And I actually didn't answer all of Pixel's questions. So then Pixel will ask me a follow-up around what I skipped over. Let's just have the next wave appear. Since each wave adds more alien rows and they move faster, should we keep the same hot pink and purples, or would you like the aliens to change color slightly? Yeah, let's have them change color to reflect difficulty. And it looks like Scribe wants to talk to us about documentation, so let's see what Pixel comes back with here, and I'm pretty sure we will just accept it and move on. All right, Pixel can pick the colors for us. Save it. Let's go see what Scribe is up to. Scribe is our documentation agent, and we can work with Scribe to create different documentation files. Let's build the readme.md file for this game. All right, so Scribe's going to go through and build us a readme.md. There it is. This is a canvas that I can actually type into and edit if I want to. I can save the documents, and I'm just going to hit save and close, or save and end, because Pixel's waiting to meet with us, and Pixel is currently gated, or gating the next task, and so I don't want to block work. All right, so here we are talking about start screen and polish. Okay. Big Space Invaders title. I like the retro approach. And let's add special effects to make it interesting. Perfect. That looks good to me. We'll hit save and end. Let's go take a look at mission control. All right, we're still implementing the wave progress. And this is cool, right? So what's happening now is I've, back on the workspace, defined what I want with 8 or 9 sentences of human English text. And right now I've got multiple agents that are simultaneously working. They're writing HTML, they're writing JavaScript, CSS, they're writing tests, they're making architectural decisions about how to structure the game engine, how to handle collision detection, how to implement a wave progression system, and all of that is derived from my intent. In traditional programming, that would be, an hour or more a day of work for me. Debugging why my sprite sheet's not loading, why the game loop has timing issues. Instead, I've just described the behavior I want, and I'm watching it get built in real time. And as it gets built up, I'm meeting with my agent team to specify the exact look and feel that I want for the game. This is the argument for spec-driven development. The bottleneck in software has never been typing speed, it's the translation layer. Taking an idea in your head and converting it to code. What if we eliminated that layer entirely? What if the spec was the program? All right, so now all development tasks are green and the test phase has begun. Remember those 2 behavioral tests that I wrote in plain English at the very start? The agents wrote real test code from those sentences, and now they are being tested. So over here we can see that our narrator is telling us that our minion Nebula Tester is making sure that everything works. Nebula Tester is putting on their detective hat, writing the tests. They're going to run the tests. We can go to the test tab. Here we scroll down. At the very bottom, we have our behavioral tests that we've defined. They're going to be handled. And Nebula is also going to make sure that everything stays green. All right, everything's green. We've got a modal pop-up here saying our nugget's complete with a little bit of a summary. We've got what we learned, breaking a job into small pieces. We wrote our first skill. The helpers are saving their work as they go. And the nugget has been tested. Now we have a couple options. We can go have a meeting with Blueprint. Let's go do that. So Blueprint's going to give us a report on the health of our system. And that report is made up of, our tests, what they're looking like, the tasks. We can see we do have failing tests here. Let's see. So we can work with a debugging agent to go fix those, and we may have to. We're going to find out in a second. And down here we have our tasks, and we can click on each task that we did and see what tests were written for that task and if they're passing or failing. But let's go take a look at the game. So when I click open in browser, it's going to open our Space Invader game. And if I press enter, I should be able to play it. Okay, and we have a pixel. Yep, I can shoot. I can get my aliens. The screen shaking as we defined with pixel. Let's see here. Oh, it looks like our lives aren't showing up there, right? We should see 3 spaceships, and I don't see that below the lives in the upper right-hand corner. Let's get hit. All right, we saw the lightning. Let's see. I am not good at this game. I want to just trigger another wave, but it may take longer than it should. There we go. All right. So we can play this game. However, we have found a bug. So I'm going to close the game out. And let's go and report a bug. So clicking that report bug option, we enter a meeting with Bug Detective, our agent. I'm going to say, while playing the game, I did not see 3 spaceships. In the upper right-hand corner, showing me how many lives I had left. Bug Detective is going to write our bug report for us. We need to show a spaceship for each remaining life. I'm going to submit that fix and hit save and end. If I go back to mission control, I can now fix my reported bugs. When I click on this button here, we get a brand new task in our task graph. We can see we have a new agent, our fixer agent, and our fixer agent has defined tests. We scroll down, and those tests should fix the bug we reported. And so it will take a few minutes here for the bug fixer agent to go through and try to fix that bug. And then we can play the game again, and we can see if the bug's been fixed. All right, so our bug fixer agent has finished their work. Let's open this game in the browser and have a look. So I'll press enter to start. All right, now I see 3 spaceships over there to the right of lives. So it looks like the bug fixer agent was able to fix our bug based on our report. And if I wasn't so bad at this game, we could try to defeat these aliens and look at the next wave. Oh, we're almost there. I also want to make sure that if I die, okay, wave 2 starts. Beautiful. All right, that works. And when I die, we lose a life up there. Now there's only 2 spaceships left. All right, now there's only 1. And last one, game over. Press enter to restart. And there's our score, looking good. I'll close out of this. I'm going to say keep working on this nugget. That allows me to come back to my workspace. I can hit save. Now what we just did is not prompt engineering. I didn't write a clever prompt and hope for the best. I wrote a structured specification, a goal, requirements, behavioral tests. I supplied a style. I supplied skills. I supplied a deploy target. Each block has a specific role in the spec, and the system knows the difference between a feature and a test, between intent and verification. And that's the key insight. Natural language programming doesn't mean type a sentence and hope for the best. It means structured natural language. You express your intent precisely, what to build, how to verify it, what it should look like, and the system has enough information to execute deterministically. The spec is the source of truth, not the code. The code is a derivative. If I change my spec, add a new feature, modify a test, change the style, the system rebuilds from intent. The code is always a faithful implementation of what I described. And we're at the beginning of this. Spec-driven development isn't going to replace traditional programming overnight, but the direction is clear. We're moving from writing instructions to expressing intent, from implementation to specification, from how to what. And what Elisa IDE does is it helps kids learn this new skill. I think the most important skill for anybody today is to be able to take an idea, decompose it down into tasks, be able to define how those tasks can be measured as complete. And once you can do that, you can build anything. And if you want to start playing with this now, you can. It's open source on GitHub. I'll put a link to the repository down below. Once you come to the repository, right now it's at version 0.1.0. I still got lots of features I want to work on, a couple edges that I want to make a little bit softer. But on the releases page, you can go and you can see both the changelog and also download. I built it for Mac OS and I built it for Windows OS, so pick the correct version for your operating system and give it a go. If you have any thoughts or if you have any issues you find, report them to me through GitHub and let's make this even better together.